In this video, we're focusing on differentiation, more specifically differentiability. So the process of finding that gradient function that we've covered in the past is called differentiation. So that's the process. So if we have something such as y equals fx, so we have some sort of function of x, and we call that the original function, right, y equals fx, then the y equals f comma x, or dy over dx, is called the derivative. Okay, and we'll go into covering how to find the derivative in another video. This is just talking about differentiability. So for something to be able to be differentiated, it needs to be continuous, right? It cannot be discontinuous. So again, a function is differentiable if it is continuous, and it's not if it's discontinuous, which means if there's a break or a gap in the graph somewhere. So below, I'm going to draw a graph that's not differentiable because when x equals a, there's going to be a gap. Now, you may have already thought of what I want to do. So if I zoom in here and put an a here, let's say that's some sort of an x value, and let's say it's a hyperbola, and down comes in my asymptote, right? That graph is not differentiable when x equals a because it doesn't exist. That's its asymptote, all right? So that is what an example of a discontinuous graph. Now, if I go down here and I draw another one, so let's say there's a B point over here, and I have some sort of graph that looks like this, but when it gets to the B, if I can just do this, like that, that hollow circle means that at that point b, x equals b, doesn't exist on the graph, so therefore that function is also not differentiable. Now an example of a graph that is differentiable is anything such as a parabola like that. We could have a curve like that, or we could have something like that. All of those graphs I just put up can be differentiated because they're smooth and continuous. One that probably can't is something like that because it's not continuous, it's not smooth, there's a point at the top there.